Hello dear students, in this video let us solve few more problems on density. Let's begin with the first question. Now let us read out the first question. What is given? An element has a body-centered cubic lattice, that is BCC, and edge length 288 picometer. The density of the element is also given, that is 7.2 gram per cm cube. How many atoms are present in 208 gram of the element? So the question is slight different from the previous questions. Okay, now let's write the data, what and all given. Let us write as it is given. An element has a body centered structure BCC, that means the value of Z is 2 since it is BCC, with the cell edge length value, symbol used is small letter A, it is equal to 288 picometer. Pico in the sense 288 into 10 to the power minus 12 meter. Okay, and density is also given. Write its symbol, small letter D is equal to 7.2 gram per cm cube. And how many atoms are, okay, so let it be still here we shall see. So Z is given, edge length is given, and density is also given. Whatever the formula we have for a density, that is equal to Z into M divided by A cube into NA, isn't it? Now, so here you can see density is there, Z is there, A cube, A value is known, and Avogadro's constant is also known to you. And the unknown term is here molar mass. So let us find out the molar mass first. Okay. So before substituting the values, let us check the units. So edge length it is in meter, and the density is in gram and centimeters. What I told in the previous class, if centimeter is given, then it should be in grams. If meter is there, then it should be in kg. So let us see in the density, it is given in terms of gram and centimeter. So now let us convert the edge length value, this meter value, into a centimeter. So let us write 1 meter equal to 100. So we can write 10 to the power 2 centimeter, and let us convert 288 into 10 to the power minus 12 meter is equal to how many centimeters. Let us do the cross multiplication here. The answer is 288. 10 to the power minus 12 into 10 to the power plus 2. It is 10 to the power minus 10 centimeters. So now let us substitute. We need molar mass. Okay. So M, let it be here. So molar mass, what happens? The formula D into A cube into NA divided by Z. Let us substitute the answer as values. 7.2, A value it is 288 into 10 to the power minus 10 to the power 3, and Avogadro's number 6 into 10 to the power 23 divided by Z value is 2. So using calculator find out the answer. The answer, that is molar mass here. So how much it is? Calculate the answer first. It is 50. I'll write directly here. I have calculated by using calculator. Okay, it is 51.79. Okay, 51.79 gram per mole. This is a molar mass. But what is the question? How many atoms are present in 208 gram of the element? Okay, see here we need to find out the number of atoms present in 208 gram of the element. So see here, whatever the molar mass you got, that is 51.79 gram per mole. You know that in 1 mole it always contains Avogadro number of atoms. So we can write like this. See, 51.79, that is equal to 1 mole of any substance. Which substance? It is any element is given. We don't know the element it is. So let it be. So 51.79, it is a molar mass. that much of grams per mole. Per mole in the sense 1 mole it contains, which is equal to its molar mass. Always it contains what? Avogadro number of atoms. 6.023 into 10 to the power 23 number of atoms. Okay. Now what is the question? How many atoms are present in 208 gram of the element contains how many number of atoms? You can directly do the cross multiplication here. You can write 20208 into 6.023 into 10 to the power 23 divided by 51.79. The answer for this 24.19 into 10 to the power 23 number of atoms. These many atoms are present in 208 gram of the element. This is one of your in-text problem. It is there in your textbook, but they have solved it in a different method. Consider one more question here. An element with the molar mass. Molar mass is given forms. So I'll write the symbol for molar mass, that is capital letter M. How much it is? It's 2.7 into 10 to the power minus 2 kg per mole. Forms a cubic unit cell. They have not mentioned the type of cubic unit cell. So under cubic unit cell we have so many 3 types, right? Simple, BCC, FCC. They have not given. Let it be. And edge length value is given. A is equal to 405 picometer. Pico in the sense 10 to the power minus 12 meter. If its density is equal to 2.7 into 10 to the power 3 kg per meter cube. What is the nature of the cubic unit cell? That means we need to find out the value of Z. What is Z? Z stands for the number of particles. If we want to calculate the value of Z, definitely we have to use the formula of density. D is equal to Z into M divided by A cube into NA. So except Z, all other values it has already given, isn't it? So molar mass is given, it is in kg, and edge length is in meters. So density is in kg and meters. So no need to do the unit conversion, isn't it? If kg is there, then it should be in meters, and if it is centimeters, then it should be in grams. So cmg, remember, here already it is in kg and meters, so no need to do the unit conversion. Just substitute the values. Okay, so we need Z value. Z is equal to, what happens? So formula becomes D into A cube into NA divided by M. So simple. This is a simple problem. So density 2.7 into 10 to the power plus 3 into A cube 405 into 10 to the power minus 12 its cube into Avogadro's value 10 to the power 23 divided by molar mass 2.7 into 10 to the power minus 2. 2.7 gets cancels. So use your calculator, and whatever the answer you'll get here, it is equal to 4. That means Z is equal to 4. What is the question? What is the nature of the cubic unit cell? If Z equal to 4, therefore you have to write the conclusion. Nature of the unit cell is, if it is equal, Z is equal to 4, then what it is? It is FCC, face centered cubic unit cell. So nature of the unit cell is FCC. Is it clear? Okay, I'll move on to the next question. Gold. Atomic radius is given. Atomic radius of gold is given. Let us write small letter r. Symbol used for radius, small letter r, is equal to 0.144 nanometer. Nano in the sense 10 to the power minus 9, isn't it? Minus 9 meter. Crystallizes in FCC, in face-centered unit cell. What is the length of a, or length or side it is, or side of the cell? What is the symbol used for? See, if you are considering FCC unit cell, this is a diagram of FCC. What is FCC? At every 8 corners, the constituent particles are present like this, isn't it? And at every 6 faces, also at the center of every 6 face, also there is a constant particle. So this is FCC. FCC. So if we denote these sides of the cube or a length of the cube or a cell as A, this is A. So they have given, we need to calculate the value of A. Only thing is they have given the radius. What is the relationship? See, only the two data you have. One is radius and edge length. No other data is given like density and volume, molar mass. It is not given. So how to solve this type of problem? This type of question may be asked for 2 marks, not for 3 marks. Just it has asked for 2 marks. So what is the relationship between edge length and R? While deriving the derivation of packing efficiency, you are very familiar with the formula, right? So in case of FCC, face centered unit cell, you are writing somewhere, you are writing like this: 4R is equal to square root of root 2 into A. This is one important formula that you have to remember it always. See, if it is a BCC, see, if it is a BCC, then what is the relationship between radius and edge length? 4R is equal to square root of 3 into A. If it is FCC, 4R is equal to square root of 2 into A. See, this is in case of FCC. If it is a simple cube or a primitive cell, then relationship between edge length and radius is A is equal to 2R. So this one you have to be remembered always. Okay. So now they have asked for FCC, face centered. So we have an important formula or a relationship between edge length and radius like this. So directly using this formula, we can directly calculate the value of A, isn't it? 4R divided by square root of 2. So R is given 0.144 nanometer. Let it be, or we can write what is the value of square root of root 2? It is 1.414, or directly in your calculator you can do the calculation. So edge length, calculate the edge length. So I got answer here. A is equal to, it is 0.4073 nanometers. This is the answer. Simple one, but it is important also. Clear? See, the last question, the same type of problem, whatever we solved in the previous session or a slide. So same type of question. What is given? Aluminium crystallizes in an FCC. Once again it is FCC. Atomic radius is given. R is equal to 125 picometers, and calculate the edge length. Direct. Since it is FCC, what is the formula or relationship between radius and edge length? It is 4R is square root of root 2 into A. So let us find out the value of edge length, that is A is equal to 4R divided by root 2, or 4 into 125, 10 to the pico in the sense 10 to the power minus 12 divided by root 2, 1.414 is equal to A. So the answer here, edge length is equal to 353.60 picometer, or you can write 353.6 into 10 to the power minus 12 meters, or directly you can write A is equal to 353.60 picometers. Dear students, this is about density problems. In my next video, I'll going to start the problems related to voids, tetrahedral and as well as in octahedral voids. I'll solve it. Thank you.